Section 3.3 is quadratic functions. I would pause the video and write down these notes. So we have two ways of writing the equation of a parabola. The first one is in what I call vertex form or transformation form. The other one is in what's called standard form. So if this first form, or in either form actually, your vertex is hk, so on the vertex form you can read that right out. On standard form, the way you can find your x-coordinate of your vertex is it's negative b over 2 times the leading coefficient a. And then to find k, you would have to plug that in and solve for y. Every parabola has an axis of symmetry. If it's a up and down parabola like we normally look at, which is all function parabolas, then the axis of symmetry is just x equals the x-coordinate of the vertex. If a is negative, it opens down and therefore it has a maximum, and the maximum value is the y-coordinate of the vertex. And then the opposite if a is positive. X-intercepts and the discriminant. So the discriminant is b squared minus 4ac, where a, b, and c are just from the original equation. So if you do that and you get a positive number, then you have two distinct real solutions, zeros, x-intercepts, roots, whatever you want to call them. If d is equal to 0, then you have one double root. And if d is negative, then you have 0 real roots. They're actually complex conjugate roots, which we'll get into in chapter 4. So this first one, we have a function in standard form. So first of all, I want you to pause the video and based off this equation, find a, b, and c. Once you have a, b, and c, you want to find h, which is the x-coordinate of the vertex, with this formula here, and k, which is the y-coordinate of the vertex. Once you find h, just plug that back into the original equation and find your y-coordinate. So go ahead and pause the video and do that. So just reading right out of the equation, make sure you keep the sign with the numbers. So a is negative 3, b is 6, and c is 1. So h, your x-coordinate of your vertex, is negative b divided by 2 times a, so negative 6 divided by 2 times negative 3, so you end up with a positive 1. So that's the x-coordinate of our vertex. For k, I plugged that in. I found f of 1. Plug that in every time I saw an x, and you end up with negative 3 plus 6 plus 1, so you end up with a positive 4. So our vertex is 1, 4. So if you graph that, it ends up being right here. Axis of symmetry is always x equals the x-coordinate of our vertex whenever we're dealing with parabolas that are functions. So x is equal to 1 in this case, and I'm going to go ahead and draw that in with just a dotted line here at the line x equals 1. So now we want to find our intercepts. We've done this before, finding x-intercepts and y-intercepts, so go ahead and pause the video and do that. So first I found the y-intercept. So y-intercept occurs when x is equal to 0, so I just plugged in a 0 for every x, and you end up with 1. So that's this point right here. Because parabolas are symmetric, I knew then that there had to be a point across the axis of symmetry right here as well, so that's why I plotted that point. The y-intercepts are when the x-intercepts are when y equals 0. A little bit more difficult. I did the quadratic formula, and once I got to this point, plug it in your calculator. You end up with negative 0.154 and 2.154. So those are those 2 points right there. And then I followed the points and came down. We knew it was down anyways because it had a negative out in front, so it had to come down and have a maximum. So in this one, we're given some information and we want to find the equation. So we're given a vertex of 1, negative 5, and a y-intercept of negative 3. So whenever we're given a vertex, the easiest form to use is the vertex or transformation form of the parabola. So go ahead and pause the video and fill in what you know. So we know the vertex, so I filled that in. H is 1 and k is negative 5. We still don't know a though, so we can use this negative 3. We're given a point 0, negative 3, and we can plug that in and find a. So go ahead and pause the video, plug in 0, negative 3 for x and y, and find your a value, and write out your entire equation of the parabola. So I plugged in 0 for x and negative 3 for y, left a, just a, and solved it out, and you end up with a to be 2. So your equation of the parabola is y equals 2, x minus 1 quantity squared minus 5. So in this one, we're given a function f of x equals x squared minus 4x minus 5, and we want to figure out if it has a maximum or minimum and what that value is. When it's asking you to find the value, it's asking you to find the maximum value or the minimum value, which is the y-coordinate. So when you're asked to find a max or a min, you answer with just the y-coordinate. So using the information from the first slide, go ahead and pause the video and answer this question. So because a is greater than 0, a is equal to 1 on this case, we know that this has a minimum, and the minimum value is whatever the y-coordinate of the vertex is. So I found the x-coordinate of the vertex, negative b over 2a, and got a positive 2. Negative times negative 4 was a positive 4, 2 times 1 is 2. And then I took that value and I plugged it back in to find the y-coordinate of the vertex, and ended up with a negative 9. So our minimum value is negative 9.